11:33 on a Sunday. No, I'm not watching football. I'm actually taking a little break. So let's talk about this. This is 7th grade material. This is the 3rd installment, part 3. This section has 15 questions, so this video will be somewhat succinct. But there's some interesting stuff, especially starting in this first question. So we've got this data. We've got data about movie A. Tables show random samples of the ages of the viewers of 2 different movies. So these are the ages of the people who are watching movie A. These are the ages of the people watching movie B. So it says the distribution for movie A is, and our choices are symmetric, skewed left, skewed right. And we're not talking about where they're sitting in the movie. We're talking about their ages. So if we took all this data and we put it in a, I don't know, we'll say we put it in if we just graphed it. So what's important, if we take the time to do this, you will notice that we have 140, we have a 41-year-old, we have 2 42-year-olds, we have 4 43-year-olds, we have 4 44-year-olds, we have 6 45-year-olds, which is kind of weird. No, that's not a, I said 6 and wrote 40, I said 45, but wrote 46. I keep writing 46. Stop it, Mr. Mac. Hiya, 45. 45, 45, and 45. We have 6 of those. That's why I keep writing. And 46, we have 4 46-year-olds. We have 4 47-year-olds. If we look at the, oh my goodness, well, I don't know what's going on. 47, we have 2 48-year-olds. And this is just, I'm taking the data from the chart that we're given. We have 1 49-year-old and 1 50. And all I'm doing is just sort of, and this is how I did it earlier. I just sat there and I ticked off, you know, I wrote 46, I wrote 47, and I just looked at the data and I just started clicking it off. So 140, 141, you got 4 42s, I know there's another 42, there we go, etc. So that's all I did was, and I've done this a couple times, so I knew what the data was going to produce. I already have that somewhere else on a sheet. But if we look, we see that this is symmetrical. So it's 1 1 1 1 2 2 4 4 4 4 and then 6. So this is very symmetrical data. So symmetrical. That's why we say trickle. And if the main data was more to the left, and we see that shift where there's more age over here, then it would be skewed to the left. If it was over here, we'd say skewed to the right. So that's what they mean here. So our answer here of our 3 choices is symmetrical. So use our choices for this are we can use the mean or we can use the median as to describe the population. Well, median would be middle, and I don't know that. I mean, that's not necessary. I would say the mean, and the mean is the average, and especially in a symmetrical data, we can use the mean. And our other choice is mean absolute deviation or interquartile range, and we're going to use the mean absolute deviation, MAD. And we saw that in part 2. Remember that last question, we introduced what the mean absolute deviation, it's the absolute value distance from the point and the mean. And we add that up and then divide by the number of numbers to describe the population. Measure of center is, well, we see what the measure of center, meaning the mean. So the measure of center is going to be 45, and also because it's symmetrical, so that answer would be 45. And the measure of variation is, so the measure of variation is going to be the MAD, the mean absolute deviation. So there's a couple ways we can do this. We can do this by each piece. We can take the distance from 40 from the mean, 41 from the mean, 42, 42, yada, yada, and we can add all those units up and then take the average. I'm going to tell you how I did it, and it was kind of nice. I used Microsoft Excel, and this is good and definitely worth me showing you how to do it. And so you're going to take that lower section. So you're going to split it. So we did this. This is how I did it. I entered in the numbers. So I entered in each number, 40. Oh, let's make this a little bit bigger so you can see it. 41, 42, 42, 43, 43, 43, 43. And there were 4 44s. And that's that data. So if we take that and we know the average is 45. So this is the average. The average is 45. So if we take the absolute difference, so equals the absolute difference of the point minus the average, which is 45, and hit, that means this difference is 5. And then I'll drag it down, and what that does is it copies it. And then if we take the average, is this what I did? I don't know why I'm, oh, no, sorry. Let's keep doing the numbers, sorry. I should do all of them. And then we had 6 45s, 4, 5, 6, and notice that the equation copied. Then we had 4 46s. We had 4 47s. We had 2 48s. We had a 49 and a 50. Now, these are the MAD values. This is the distance from the mean. So we're going to take all of these distances and we're going to find the average of it. So we can do average, and then we do B sub 1 colon B sub 30. So that's just taking the average of all those values, adding them up and dividing by 30, and we get, ding, 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 1.8. So this is the MAD value right here. The MAD value is 1.8. So we take each number and subtract it from the average. The average was 45. So we took that number, subtracted it from 45, and we took the absolute value. We took just the distance. So that's 5 from the average, 4 from the average, and we did it for each of the individual data points. And then we added up all those all those distances, and then divided it by the number of numbers, and we got 1.8. So this value right here is going to be 1.8. Most of you didn't know that answer, which is fine. I mean, this is just the MAD value. It took me a little time to figure that out, so that's very reasonable. I like using Excel to help me when I have lots of numbers like this instead of, and that's a way of utilizing technology. The distribution for movie B is, and if we take all these values and plot it out like we plotted this, you will notice that this also is symmetrical. That is also a symmetrical distribution. And so we would again use the mean N, the MAD value, to describe the population. The measure of center this time is going to be 31. That is going to be that middle of that of this data, all the data points. And the MAD, again, how weird is that? The MAD, the mean absolute deviation, is 1.8 also. So that's kind of weird. So the ages of viewers of movie A are generally blank. So our choices here are going to be greater than, less than, or the same as. So A, we see that the average age of the viewers was 45 for movie A, 31 for movie B. So the age of viewers for movie A are generally greater than. Greater the ages of viewers of movie B. A lot of work, and it's intimidating because there's a lot of questions for us. Now, I like that they gave you multiple choice so you could narrow it down a little bit. I know that there's a lot of data points in both of these. That's 5 by 6, so there's 30 data points. So this is not a 1-minute problem. As I always say, hey, we want to shoot for 60 seconds to complete these problems. But this had 11 questions. So technically, we could assume that we could spend about 11 minutes on this problem. So hopefully you learned something and you're getting better at the mean absolute deviation, because clearly that is something that they want you to know. After this question number 1, problems get a whole lot easier. Not to say that it isn't confusing, because there is some interesting things that are going to happen starting with question number 2, but at least they're a little bit more straightforward. It says, find the circumference of the circle, round your answer to 2 decimal places if necessary. So when we have circumference, we have 2. It can be 2 pi r when given the radius, or c equals pi d when given the diameter. This is a diameter. So I'm going to use this one. C equals 3.14 times the diameter, which is 38. And if we do that in our calculator, we get 119.32. And so round to 2 decimal places, I would say 119.32 feet. Unfortunately, the book is contradictory. So when you do this value, it tells you that it's wrong. And the value that they give you in the answer key is 119.38. And the way that is they use the true value of pi. So they went and just used this larger number for pi, which is programmed in there, and then they multiplied it by 38, and they got 119.3805, blah, blah, blah. They rounded it to 2 places, and they, in the answer key, says 119.38. So at this point, you could go, okay, apparently they want us to use the more exact value for pi. So in your future problems, you would use the calculator for pi. Hold on a second. So in the next question, find the area of the circle, round your answer to 2 decimal places. It looks completely the same. Difference is you're going to use area equals pi r squared. And here we know that we're going to use pi, the calculator value for pi. The radius, this is again the diameter. So I need to calculate that the radius is going to be half the diameter, or 12 centimeters. So we get 12 centimeters quantity squared, which would give me 144 pi centimeters squared. Now, I wonder if they allowed you to do that, to write 144 pi. But knowing that we would want to use the calculator, so we would do pi times 144, and that would give us 452.389, and it would lead us to believe that we would have to round that to 452.39. So I would assume, since I got number 2 wrong because I used my 3.14 value, that that number, 452.39 centimeters squared, would be the correct answer. No, it's not. For some reason, on this example, they want you to use the rounded version or the approximate version of 3.14 centimeters squared. And so if you do 144 times 3.14, you get 452.16. 452.16 centimeters squared. For some reason, this is the correct answer for this problem, and this is the correct answer for this problem. It makes no sense. They've changed it. Here they use the longer pi value. Here they use the approximate pi value. So I don't know how you're supposed to know. They ask the same questions. They have the same symbols, approximation, approximation. I don't know why they chose one for one and the other. So as long as you show your work, and as you know, Mr. Mack will accept multiple solutions for this. So I apologize for the confusion. Great comprehension question for number 4. I love this question. This is something that is explained. Is it possible to construct a triangle with the given lengths, 3, 5, and 9? And you have to use logic here. So the logic of it is, if we had 3 feet and 5 feet, could this third side be 9 feet? Could it be 9 feet? No, it absolutely can't be 9 feet. That cannot be a triangle. Why? Because if we straighten this out, if we put this as a straight line, you'd have 3 feet, you'd have 5 feet, and this adds up to 8 feet. So there's no way that this can be 9 feet. This side has to be less than 8 feet, because a triangle is not a straight line. It has to have 3 sides. If it's straight, the maximum would be 8. So this triangle, this value needs to be less than 8 feet in order to be a triangle. Kind of cool. Don't know if you've ever thought about that logically, but this is a great question. So I like this. This is a real deep understanding of triangles, their sides, the hypotenuse. So good question. Find the value of x. We know that this angle is congruent to this angle because they are vertical angles. Vertical angles are congruent, so we know that x plus 6 must equal 41 degrees. We're going to minus 6 from both sides. We get x equals 35 degrees, and that is your missing value. Another good question. Very, very 7th grade material, very pre-algebra. Find the surface area of the cylinder. Round your answer to the nearest tenth. We again are going to have to use pi here, so the surface area of all cylinders has this template, 2 pi r h plus 2 pi r squared. This is a logical, if we slice this lateral area, right, if we slice off the top, slice off the bottom, you have a circle, you have a circle, this is your top, this is your bottom, and then your lateral area, if you slice this and unwrap it, is actually a rectangle. That's the lateral area, the waist. And that length is actually the circumference. That's the distance around the circle. If we follow it all the way around, that's the circumference, so 2 pi r. And then this distance actually is the height of the cylinder. So when we look at area, area is length times width, so you get 2 pi r h as the lateral area, and then your two circles. And the area of a circle is pi r squared, pi r squared. So that's where we get the 2 pi r squared. So if we want to start looking at where these values come from, that's the bases, the top and the bottom, and the lateral area is going to be that. So this is surface area equals lateral area plus base area. So we can use this template for any type of cylinder, and we want to find the surface area. So let's take this formula and let's start plugging in the values. Can't do that, forgot about that. Okay, let's do this. Let's do this problem underneath here. So surface area equals 2 pi RH plus 2 pi r squared. Surface area equals 2 times 3.14 times the radius. The radius in this problem is going to be 6 times the height, which is 16.8 plus 2 times 3.14 times the radius squared, which is 6. So surface area equals 6.28. That's 2 times 3.4 times, this is 100.8. That's 6 times 16.8 plus 2 times 3.14 is 6.28 times 6 squared is 36. Some advanced math, we notice that we're multiplying by the same 6.28, so I can factor that out, and I can add these two values, whoa, and that gives me, and just to make less calculations, 6.28 times 136.8, and then we can do that in the calculator, and we are going to get surface area of 859.1 centimeters squared, rounding to the nearest tenth, I think it says, round to the nearest tenth. And then if we use pi instead of 3.14, the other value you would have gotten is 859.5 centimeters squared. Remember, surface area is going to be squared units, so using either one, it's fine. I would accept either value. So this is a formula you should absolutely know from 7th grade. Surface area of cylinders. The base of a hexagonal prism, so a hexagon and prism means that it's going to be two bases. I guess it would look like that. And so that would be our hexagonal prism. The volume of all prisms, volume of a prism is going to be big B times H, where B is the base area and H is the height of the figure, meaning the distance between the two bases. So it tells us that it has a base area of 48 inches. So that's going to be my big B. I don't have to worry about how to find the area of a hexagon. They've already given it to me. And then it tells me that the height, the distance between the two bases is 4 inches. So this is actually a really easy, simple. We're going to put 48 squared inches, so we could write that times 4 inches, which is the height, and that gives me 192 inches cubed. So super easy, super nice, and we can do a little bit more highlighting. This is the base area, so that's going to be 48 inches squared, and then we multiply it by the height, which is 4 inches. That's all we're doing here. This is another good one. This is interesting. There's some very, very cool, especially with that bottom figure on when intersections on cones, what do what do they produce? So match the figure with the description of the intersection on the plane. So this is this is kind of easy to me. The intersection is a triangle. We see the triangle right there. The intersection is a rectangle. Well, we kind of see the rectangle right here. And the intersection is a circle. We see the circle right there. So I would drag each of those into the corresponding. So this goes here, this goes to the middle, this goes right here. So that to me was pretty simple. Hopefully everybody got that right. I haven't got the percentages out there yet. We'll do that at a later time. The base of the triangle prism is a right triangle with a base of 10 inches and a height of 24 inches. The height of the prism is 30 inches. So this time they don't give you the area of the base, they give you the dimensions of said base. So you have a triangular prism. So we're going to go up like this. And it looks like this. And that's a right angle. Because it says the base has a base of 10 inches and a height of 24 inches. They need to be perpendicular to each other. Since it said height, we know that the height's always going to be perpendicular to the base in any triangle. And then it tells the height of the prism is 30 inches. So I want to make sure I'm in all the same units. So this time we know volume equals big B times H because it's a prism. And my base shape is a triangle. So that's base times height divided by 2 times the height of the object. This height is of the base. This height is of the prism. So my base is 10 inches times 24 inches divided by 2 times the height of the object, which is 30 inches. And I can simplify this. I'm going to cross cancel, make that 12. And now I have 10 inches times 12 inches times 30 inches. I'm probably going to multiply 12 inches times 30 inches, which is 12 times 3 is 36 with the 0, which inches squared. And then I'm going to multiply it by the 10 inches because I can do that number a whole lot easier without using a calculator. So we're going to say that the volume equals 3,600 inches cubed. Nice. No calculator. We just use logic here and simple math. Number 10, the base of a hexagonal pyramid has an area of 36 square inches. The height of the pyramid is 2 inches. Find the volume of the pyramid. So this time we have a pyramid. So we need to understand that a pyramid is going to be a little bit different. So that goes up like this. This is hidden. This is seen. This is seen. This is seen. And this one is hidden. So the base area. So this time they give us the area of the base. And then the height of the pyramid is 2 inches. And I don't know if I'm going to use this one. Sorry. That's my lovely wife. I'm going to have to send her to voicemail and tell her that I'm making a movie. Hold on. Making a movie. I'll call you in 5 problems. Because we're on problem to actually 6 problems. Hopefully she says that's okay. Let me erase this. And let's go back to this. So I like this color. 2 inches. The height of a pyramid has to go from the center. We have the difference of a slant height, and our height is from the base to the top of the object. So that's going to be 2 inches, okay? So that's really important that we understand the difference. Now, also, volume of pyramids is going to be 1/3 big B times H. Big B still stands for the base area, the green part, but we have to take 1/3 of that measure. So this is still a plug and play. They've given us all the information that we need. 1/3, the base is 36 inches squared. She hasn't responded, which is not good. 2 inches, so hopefully all is okay. And let's cross cancel. 3 in the denominator, 36 in the numerator. We have 12 inches squared times 2 inches squared will give us a value of 24 inches cubed. And that would be the volume of this hexagonal pyramid. Really good. You see how nice and easy, well, not easy, but you see how nice this is, right? This is very doable when we have a good knowledge of the material. Number 11, each person in a group buys a movie ticket, a drink, and a popcorn. How much does the group pay when there are 4 people in the group? So everybody's going to get a ticket, a drink, and a popcorn, and I'm going to add those values up. I'm going to add 7 plus 225 plus 3, and then that would be the total cost for one of those packages, and I'm going to multiply it by 4. So let's do 4 times, if we add 7 plus 225 plus 3, that's 1225 times 4. We can sort of think of 4 times 12 as 48 and 4 quarters as $1. So that's 48 plus one more dollar, which is 49. Don't know if you see that. That's sort of equal to 4 times 12 plus 0.25. And if we distribute that, 4 times 12 is 48. 4 times 1/4 is 1. That's how I did it mentally again. So that will give us $49. Number 12, you install 580 feet of fencing along the perimeter of a rectangular yard. The width of the yard is 144 feet. What is the length of the yard? So we've got this yard that is a rectangle. It's a rectangular yard. And let's think about, we're going to use 500 feet of fencing along the perimeter. They even give us it along the perimeter. So this is going to be, if we add up all these distances, it's going to equal 580. So we know this formula, P perimeter equals 2L plus 2W. Okay, so we know that P is going to be 580. The width of the yard is 144 feet, so this is 144 feet. This is 144 feet. So, and then what is the length? So we want to find the length. We don't know what L is. So we don't know what L is. We know what the width is. And now we're only missing one variable, so we can simplify. 580 equals 2L plus 288. Let's subtract 288 minus 288. That gives us 292 equals 2L. Divide both sides by 2. Divide by 2, and we get 146 equals L, and that needs to be in feet. So it's 146 feet is the length. Of the rectangular yard. Good? Good. Okay. Number 13, it says in a game you pilot a spaceship and gain a point for every asteroid you destroy. The game ends when your ship is hit by an asteroid. You already have 45 points. Graph your possible final scores for the game. This is a horrible question because you don't know if when your ship is destroyed by an asteroid, do you also destroy the asteroid, or do you just destroy the ship? It's not enough information. They're trying to be tricky. So if your ship gets destroyed by an asteroid and it destroys the asteroid, you would have at least 46, because you have 45, and then you get a point for the asteroid that also destroyed your ship, but you destroyed the asteroid. So to me, it would have to be at least 46 points, but we're making the assumption. So the answer, and looking at our choices, your final score is at least 45 points, because even if you don't know, you know that you have 45 at the minimum. Your final score is less than, no, that's not going to be you don't get minus points. Your final score is at most, no, that means the most you can make is 45. No, your final score is greater than 45. Yeah, I like that. To me, that could have been the other alternative answer. But in the book, it says your final score is at least 45. To me, I assume maybe I'm overthinking it. I don't like this question. It's a bad question. Number 14, find the constant of proportionality k in the equation y equals 28x. We need to know that when things can vary directly, which is what they're saying, proportionally, you have this formula, y equals kx. Now, the other is when it is an inverse variation. It varies inversely. Variation. If it varies inversely, you get y equals k over x. X is in the denominator, but that's not the case. It tells you it is proportionally. So we know that we're dealing with varies directly. So the coefficient of x is going to be our k value. So k equals 28. That's how easy that question was. Yeah. And we again stick with varying proportional relationships. So we know that y equals kx, and we're given x and y values, so we can plug in these values. You can plug in any set of these values as long as you do its corresponding x and y. So if x equals 1 and y equals 54, we can substitute that in, and we get k equals 54. So that's my k value, understanding that we're going to work in this template. And if we use this one, let's use a different set. What if we plugged in 0.5 and 27? 27 for y, 0.5 for x. We would divide by 0.5, divide by 0.5, and we still get 54 equals k. And we'd get it no matter what, because that's going to be a function that we can use. All right, congrats. You're done with these sections. These are the solutions that they provided you. Some are similar, some are depending on what value for pi you use. So good luck, keep working on this stuff, especially mean absolute deviation. Have a good one.